the actual output of a machine learning. So yesterday itself, we talked about the evaluation of machine learning also. What is called evaluation of machine learning? How do you predict? How do you believe machine learning? Machine learning is always a prediction, or it gives you a summary report. On what basis it gives you the summary report? There are totally 4 models, my dear friends. They are geometric model, probabilistic model, logical model, and grouping and grading models. There are 4 models by which it gives you the summary report. Let us discuss in detail about these 4. Of course, geometric model is completely one unit. Probabilistic model is another unit. Logical model is another unit. Grouping and grading is another unit. But in this particular basic unit, we will be learning brief introduction of all these models. Now, what is a geometric model? A geometric model, you can see here, is constructed directly in instant space using geometric concepts such as lines, planes, distances. So one main advantage of using geometric classifier is that they are easy to visualize. What do you mean by visualize? So you have already seen Python. What do you mean by visualization? Visualization, bar charts, pie charts, then skew charts. So all these things are very good to visualize the data. Visualize the data. So as long as we keep 2 or 3 dimensions like x-axis, y-axis, z-axis, the data can be plotted in these with graphs and visualize the data in a very easy manner, and thereby decision making would be very useful. Now, you have to know the basics of geometry. Basics of geometry, like what is called linear transformations, distance metrics, and then analyze the data to solve such problems. So mathematics, without mathematics concepts, see for example, if you take the example of no automated driving system, automated driving system. In that case, no, you have to calculate the pedestrian who is walking before your car. Now, how much the distance is, and what is the speed at which you are going, and whether the pedestrian cross the road before you reach the pedestrian, or you have to slow down the car. So such calculations can only be done by using this geometric model. Without this geometric model, you cannot estimate such real life things. No, definitely in some problems, geometric model is not required. But for many major problems, all these geometric problems are required. For instance, let us see a small example, how geometric model look like. So a linear decision boundary is defined by the equation Wx is equal to T, where W is a vector. Vector means it's a point. It is given as with two values. And W is a perpendicular vector to the decision boundary. Decision boundary. X points to an arbitrary point on the decision boundary. P is decision threshold. Now the basic linear classifier construct is decision boundary by halfway intersecting the line between the positive and negative centers of mass. So it is described with the equation Wx2 is equal to T, with W is equal to P minus N. The decision threshold can be found by noting that P plus N by 2 is 1 is on the decision boundary. Now, see, this is how mathematics is used in our decision calculation. In the same way, I think you all might be knowing what is the distance, how we calculate the distance. There are 2 methods called as Euclidean distance and Manhattan distance. The formula for Euclidean distance is square root, and Manhattan distance is sigma d I tends to 1 mod xi minus yi. So this is how mathematics. So you need to know even some geometrical mathematic models in order to achieve this particular machine learning in an easy manner. Now the next one is probabilistic classifier. Probabilistic classifier. What is called probability? Probability. You should know what do you mean by probability. You all might have learned probability in your intermediate second year, but still, what is probability classifier? A probability classifier that is able to predict. See, if you raise a coin, what is the chance of getting a tail? What is the chance of getting tail, and what is the chance of getting head? Now, for this, you also have to calculate how many times the coin has been given. So, if 10 times the coin is given, what is the possibility of getting, no, 5 heads and 5 tails? So, this is how the probability is calculated. This probability is estimated, is given as the estimation or prediction, is used for prediction. Now, what is actually probability? Probability refers to the chance or likelihood of a particular event taking place. So what do you mean by event here? Even if throw a coin throw చేసినప్పుడు హెడ్ వచ్చేది అని చెప్పడాన్ని ఒక ఈవెంట్ అంటారు. టెయిల్ వస్తుంది అని చెప్పడాన్ని ఒక ఈవెంట్ అంటారు. An experiment is a process that is performed to understand and observe possible outcomes. ఎక్స్పెరిమెంట్ అంటే ఏంటి? ఇప్పుడు కాయిన్ ఇసిరేసాం, ఏమొస్తుంది? ఒక టైల్ రావచ్చు, ఒక హెడ్ రావచ్చు. అలాంటి వాటిని అవుట్కమ్ అంటారు. అవుట్కమ్ అంటే హెడ్ రావటాన్ని అవుట్కమ్ అంటారు, టైల్ రావటాన్ని అవుట్కమ్. శాంపుల్ స్పేస్ అంటే ఏంటి? Set of all such outcomes come under sample space. So all these basics are required to learn machine learning. Right. Now, some more basics of probability. Probability of an event A is defined as the ratio of two numbers m and n. P of A is equal to m by n, where m is the number of favorable occurrences of A, and n is the total number of occurrences of outcomes of the experiment. Suppose if you throw the coin for say 6 times, suppose in that case 2 times head has come for 2 times and tail has come for 4 times. If consider a small example, then P of head, A is here head, A is head. P of A would be 2 by 6. And P of tail will be 4 by 6. That is called probability. That is how we calculate the probability. Consider an example. Now, if you consider this an example, it will be very clear to you. In a manufacturing unit, 3 parts from the assembly are selected. 3 parts are selected. You are observing, no, 3 parts. I have taken 3 parts. I am just observing whether they are defective or non-defective. Now the question is, determine what is the sample space and determine the event of getting at least 2 defective parts. You have taken 3 things into your hand and you are checking which one is defective and which one is good or which one is non-defective. Now, what is called sample space here? Now, you can see here. Now, if you see here, see, they have given us 3 things. They have given us 3 things here. One is So how do you defect? So you have so three parts chosen. So a defective part is chosen as D and a good part is chosen as G. For suppose, what is the sample space? So sample space, so what are all the possibilities? Can be Z, Z, Z. So the three are Z's, three G's. That means I have taken three parts, three are in good position. That is one possibility, one possibility. Then Z, Z, D. Two are good position and D, one is defective. And what is another possibility? G, D, Z. So this is also good, defective, and good. So one more possibility is good, defective, defective. Similarly, you take defective, good, good. Defective, defective, good. Defective, good, and defective. And all are defective. This is called sample space. You cannot get any, see, you have taken three parts. The all possible parts are these eight. These eight. So all can be good. All are good. The first two are good. One is bad. The first one is good. Second one is bad. Third one is good. First one is good. Second one is bad. Third one is bad. The first one is bad. Second one is good. Third one is good. First two are bad. The third one is good. First is bad. Second is good. Third is bad. All three are bad. Now, we were asked to find out what is the probability of getting at least two parts are bad. No, what are the two minimum two parts are bad? So what are all the possible space possible events? See we can see here ZDD is our event. So we have to write ZDD is one thing, DDZ one other thing, DZD is another thing. So do you have ZDD, DDZ, DZD, and DD? So these are all the four possibilities where our problem come into existence. The event of getting at least two defective parts, at least two defective parts. Now, so what is the probability of getting this? What the probability here is can be calculated. The total number of total space is 8. And now for our instance, for our problem, there are 4 events. So now our probability of getting, our probability for our problem is almost, it is 4 by 8, that is 0.5. This is how probability is measured, my dear friends. And for this, how this probability is useful for our machine learning, we will be learning in the second chapter, second unit. And so I'm just giving you, so if you have a chance of learning probability from your intermediate lecturer, I request you to do so, to learn. And I once again tell you that the future is completely machine learning and AI. The future, software future is completely machine learning. So I request you all to kindly have a look at this. Right. Now, some addition rule. No probability, if you want to talk about probability, there are many things: addition rule, subtraction rule, multiplication rule, Bayes theorem, everything is there. We'll be coming up, we'll be going through all these things in the second unit, but still, just two events, A and B, are said to be independent. If the occurrence of A is in no way influenced by the occurrence of B. For example, if you throw a coin, you'll get head. If you throw the coin second time, is it dependent on the first time? First time వచ్చిందే మళ్ళీ second time రాకూడదని rule ఏం లేదు కదా. So that is called independence. Independent. So independent. So first time అది వచ్చింది కాబట్టి second time ఇది రాకూడదు. So but there is a chance. For example, if you consider a lottery. ఒక లాటరీలో ఫస్ట్ ఒక Sonovision. There is a TV shop called as Sonovision. They have given a lottery system. They have placed a lottery system. If you buy a TV, they'll give you a scratch card. What you have to do is you have to fill the scratch card and you should put it in a box. And one day they'll be taking it as a lottery and see the probability there. If one is picked for the first one, and that is taken into consideration, and prize is given to the first one. And remember, my dear friends, now the sample space is reduced by 1 because that person's ticket is taken out. And is taken out. He has given ticket. So now the probability of the other is dependent on the first one. Dependent. Now in this case, it is not dependent. So there is dependency and not independence. This is very important. So if one is influenced by the occurrence of others, then it is called A by B. So what is the chance of A given B? Something like this. So and now P union B is equal to P of A plus P of B minus P of A intersection B. All these things, no, you have to learn, my dear friends. This is very important. You have to learn. Now, in the same way, so what do you mean by bias theorem? Bias rule. Bias rule. A model describes data that could be observed from a system. So our intention of machine learning is to observe the data, to describe the data, describe the given data in a with a summary which gives you a better idea to take a decision. If we use mathematics of probability theory to express all forms of uncertainty and noise associated with our model, then inverse probability allows us to infer unknown quantities and adapt to our models. This is called bias rule. Bias rule under make predictions from the learned data. This is called bias theorem, bias rule. P of A by B is equal to P of B given A into P of A by P of B. This is called bias rule. You can have you can see with an example also. First, in general, the result of P of A given B is referred to as posterior probability, and P of A is referred to as prior probability. So these terms are relatively new to computer science students, but these are all you all might be knowing all these and these terminology in intermediate itself, but still, so if you do not understand this probability or this terminology, I request you once again to just have a look at your intermediate mathematics notes, especially probability. Right, sometimes P of B by A is referred to as likelihood and P of B is referred to as evidence. Now, P of B by A is called likelihood, P of B is called evidence. This allows bias theorem to be restated as posterior is equal to likelihood into priority by evidence. Now, let us take a small example. If weather is sunny, then the player should play or not. How do we estimate this? Assume that there are 14 items. So I have, because of the space, I have cut it into, I have placed only 3 parts of this. So weather, yes, no, overcast, 5, 5, 0, rainy, 2, 2, sunny, 3, 2, and total. So 5 plus 2 plus 3, 10, and here 2 plus 2 plus some 1 is missing, 5. So right. Now P of S by Sunny. S by Sunny. How many S? There are 3 S. Sunny. There are 3 Sunnies in S. So 3 by 10, the probability is 0.3. Similarly, what is the probability of Sunny? P. So 5 by 14. Sunny is 3 plus 2. So this is 5 is wrong, Andy. So this is 4. So I request you to kindly consider. Right? 5 by 14. 5. So 3 plus 2, 5 by 14, it is 0.35. So P of Sunny is 5 by 14. So that is 0.35. What is P of S? Yes, total number is 14. 10 by 14, it is 0.71. And then P of S by Sunny. Yes, because of Sunny. Yes, because of Sunny. That is, so it is given in the formula like something like this. P of B by A into P of A by P of B, with that 0.3 into 0.71 by 0.35. That gives you 0.60. So now we can infer. We can infer. We can infer. See, yes by Sunny is 0.60. Similarly, what is no by Sunny? See, yes by Sunny. Sunny day, on a sunny day, whether a player should play or not. This is the question. So yes by Sunny gives you 0.60, and no by Sunny in the similar way. If you calculate, you'll be ending with no by Sunny is 0.541. That is, so probability of yes by Sunny is 0.60 and the probability of no by Sunny is 0.41. Hence, on a sunny day, player can play the game. With this probability, we suggest them. We have given a summary report that yes, the player can play. Can play. That is their wish and will. Whether they play it or play for it or not. That is. This is just a model. This is the model. This is called probabilistic model. Hope. No, it is very difficult, my dear friends, to understand at one instance. But no, you should be thorough with the probability, mathematics. So unless you are good at mathematics and maybe probability statistics, you definitely cannot understand machine learning. But still we will try. I'll try my level best to make you understand even this mathematics and probability. Hope you understood, right? So let me just conclude. So today we discussed machine learning output to models. We have totally 4 models: geometric model, probabilistic model, logical model, and grouping grading. These are the 4 models by which the output of machine learning outputs. And geometric model entirely deal with mathematics, formulas. This is no geometric. What do you mean by geometric? No, calculating the distances and plotting graphs between x-axis and y-axis. For example, if you want to find out how many sales are there today, or what would be the percentage of sales tomorrow, so we can plot a graph, a bar chart or something like this. Here we on x-axis we put days, on y-axis we put the number of sales, so that we can easily understand what is the what is the chance of, we can estimate. That is how geometric is things are used. Similarly, what is probabilistic classifier? In probabilistic classifier, we use completely probability, statistics, probability. In probability, we need to know what is called an event, what is called a sample space, what is called an experiment. So then what is a probability? Well, how do you calculate a probability? P of A, where A is an event. Probability of event is equal to M by N, where M is the number of occurrences, favored M, favored A, favored A, and N is the total number of occurrences, total number of experiments. How many times you have done the experiment. So this is how it is calculated, and you can even consider an example. If there are three parts chosen, what is the possibility of all three are good, all three, no, what are the sample space you can see here, ZZZ, ZZD, ZDZ, ZDD, something like this. And you can see the total space is 8, and the P of A, our case is the event of getting at least 2 defective parts. There are, what are the two defective parts? You know, see GDD, DDG, and DGD, and triple D. So total 4 by 8, it is 0.5. That is how probability is calculated on bias rule. All these things, by using all these things, we can estimate. This is what probabilistic experiment. So these are the models we discussed, and in the next class we will discuss logical models and grouping and grading. Thank you, and if you have any doubts, you can share with me. And not the least, I have to express my thanks to especially final year students, especially Kavita and 544, who have used మన కాలేజ్లో మన స్టాఫ్ డెవలప్ చేసుకున్నటువంటి సాఫ్ట్వేర్ని యూజ్ చేసుకొని they have generated, they have got the fee paid certificate. ఆటోమేటిక్గా వాళ్ళు ఫీ పే చేశారు, త్రూ ఫోన్ పే ద్వారా పే చేశారు. ఆ ఫోన్ పే ద్వారా పే చేసిన డీటెయిల్స్ అన్ని కూడా మన సిస్టమ్ ద్వారా వాళ్ళు ఎంటర్ చేసుకున్నారు. ఎంటర్ చేసుకున్న తర్వాత